Try to close your eyes for a moment and imagine the entire history of the blue planet we call home. Not as a number written in a textbook, not as a cold, scientific timeline, but as a violent, breathtaking journey through fire, darkness, oceans, monsters, extinction, survival, and finally, us. Earth is about 4.5 billion years old, a number so immense that the human mind almost collapses trying to understand it. Our lives last only a few decades. Our civilizations have existed for only a tiny fragment of that enormous history. Yet before the first human ever opened his eyes, before the first animal ever walked on land, before the first forest ever touched the sky, this planet had already survived disasters so extreme that they could erase entire worlds. Earth was not born gentle. It did not begin as a peaceful blue sphere drifting beautifully through space. It was born in violence. In its earliest age, there were no oceans, no continents, no breathable air, no green valleys, no birds, no animals, no human voice, and no life of any kind. There was only heat, impact, poison, gravity, and fire. The young planet was a molten body, a glowing sphere of lava and metal, constantly bombarded by debris left over from the formation of the solar system. Every collision released energy beyond imagination. Every impact reshaped the surface. The sky was not blue, but dark, toxic, and suffocating, filled with dust, sulfur gases, carbon dioxide, and steam rising from the burning ground. If you could stand there, even for a second, you would not simply die, you would vanish. But from this nightmare, the future of life was being prepared. Deep inside that fiery chaos, heavy elements sank toward the center, forming Earth's core. Lighter materials rose and began shaping the outer layers. The planet was organizing itself through destruction. It was building the hidden machinery that would one day create magnetic protection, volcanic activity, continents, oceans, climate, and the conditions necessary for life. Before Earth could become a cradle, it first had to survive as a furnace. And the greatest collision in its early history was still approaching from the darkness. Sometime after Earth's formation, a wandering planetary body, roughly the size of Mars, moved into a fatal path. Scientists call this ancient object Theia. It was not a small asteroid. It was a young world, massive enough to destroy everything on contact. Gravity drew it toward Earth in a collision that would change the destiny of the planet forever. When Theia struck, the impact was so violent that the outer layers of both bodies were vaporized. Rock became gas. Metal melted. The young Earth was almost torn apart. The energy released was greater than anything humanity has ever produced or even imagined. But destruction in this case became creation. Thea's iron core sank deep into Earth and merged with its interior, strengthening the planet's internal structure. Around the wounded Earth, trillions of tons of molten debris were blasted into orbit, forming a glowing ring of shattered rock and dust. Over time, gravity gathered those fragments together. They collided, melted, fused, and slowly became the Moon. In its earliest form, the Moon was much closer to Earth than it is today. Huge in the sky, red with volcanic heat, scarred and glowing like a second world watching over the first. Its birth was one of the most important events in Earth's history. The Moon stabilized Earth's axial tilt, helped regulate tides, and gave the planet a more stable rhythm. Without it, Earth might have wobbled chaotically through space, with extreme climate shifts that could have made complex life impossible. The same collision that nearly destroyed Earth may have made Earth habitable. That is one of the strangest truths of our existence. We owe part of our survival to a disaster. After the impact, Earth began a long process of cooling. The endless magma ocean slowly hardened into a dark, cracked volcanic crust. Volcanoes tore through the surface, releasing enormous amounts of gas and steam. The planet was still hostile, but something extraordinary was beginning to gather above it. Water vapor thickened the atmosphere. Clouds formed over a world still burning below. The stage was being prepared for the first great rain. As Earth cooled, its atmosphere became heavy with vapor. Some of that water may have been released from the planet's own interior through volcanic activity. Some may have arrived through icy comets and water-rich asteroids that struck the young surface again and again. For a long time, the ground was still too hot for liquid water to remain. The first drops of rain would have touched the volcanic crust and instantly turned back into steam. But the planet continued to lose heat into space. Eventually, the rain did not stop. It became one of the greatest transformations in Earth's history. Storms poured over the black volcanic surface for vast stretches of time. Rain filled craters, carved channels, gathered in low places, and slowly formed the first oceans. Fire gave way to water. But these ancient oceans were not peaceful blue seas. They were dark, acidic, mineral-rich waters under a strange sky, perhaps orange or reddish because of the gases in the atmosphere. There were no beaches, no fish, no coral, no seaweed, no sound of animals. Only waves beating against barren volcanic rock. Yet deep beneath those waters, in places sunlight could not reach, something impossible was being prepared. At the bottom of the ancient ocean, cracks opened in the crust. Cold seawater seeping downward touched hot rock and blasted back upward through hydrothermal vents. These black smokers released heat, minerals, hydrogen sulfide, iron, and chemical energy into the deep sea. There, between freezing darkness and volcanic fire, chemistry began to cross a mysterious boundary. Simple molecules collided, combined, separated, and recombined for immense spans of time. Carbon, hydrogen, oxygen, nitrogen, and other elements formed increasingly complex structures. Some molecules gathered inside fragile membranes, creating tiny protected spaces separate from the outside world. And then, somewhere in that darkness, something appeared with a power no rock, ocean, or mountain possessed. It could copy itself. The first life on Earth was likely microscopic, fragile, and simple. It had no eyes, no brain, no bones, no voice. But it carried the most revolutionary ability in the universe: replication. From that invisible beginning, every living thing on Earth would eventually descend. For an unimaginably long time, life remained invisible to the eye. Earth had oceans, storms, volcanoes, and crust, but no forests, no animals, no plants, and no creatures moving across the land. Life existed as microscopic organisms drifting in water, clinging to rocks, surviving in chemical environments, dividing and adapting with extraordinary patience. If you had looked at the planet from space, you might have believed nothing meaningful was happening. But evolution was working quietly. Eventually, a group of microorganisms changed the world more dramatically than any animal ever would. These organisms, known as cyanobacteria, learned to use sunlight as an energy source. Through photosynthesis, they used water and carbon dioxide to produce food. But this process released a waste product into the environment: oxygen. Today, oxygen is the breath of life for humans and animals. But in the ancient world, oxygen was dangerous. It was chemically reactive, destructive to many early organisms, and toxic to life forms that had evolved without it. As cyanobacteria spread, oxygen began accumulating in the oceans. It reacted with dissolved iron, causing massive amounts of rust-colored iron oxide to sink to the seafloor. The seas were chemically transformed. Eventually, after the oceans absorbed as much oxygen as they could, oxygen began entering the atmosphere. This event changed the planet forever. It created the foundation for complex life, but it also triggered one of the earliest mass extinctions. Life itself had poisoned much of the life that came before it. Then the consequences became even more dramatic. Oxygen reacted with methane, a powerful greenhouse gas that had helped keep Earth warm. As methane levels fell, the planet began losing heat. Ice expanded. White surfaces reflected sunlight back into space, cooling Earth even further. The planet entered a catastrophic frozen state, often called Snowball Earth. Oceans may have been sealed beneath thick ice. The surface became silent, white, and hostile. To an observer in space, Earth might have looked dead again. But life survived in hidden places, deep under the ice, near volcanic vents, in pockets of warmth and chemical energy. Even when the planet became a frozen tomb, the flame of life did not go out. Earth escaped its frozen prison because its interior never stopped burning. Volcanoes continued releasing carbon dioxide into the atmosphere, and with much of the surface locked beneath ice, the oceans could not absorb it efficiently. Slowly, heat returned. The ice cracked. Water flowed again. Life had survived one of the most extreme climate disasters in Earth's history. But after that rescue, the planet entered a long, quiet age. For an immense stretch of time, there were no forests, no predators, no giant animals, and no roaring kingdoms. The oceans were still ruled by microscopic life. Yet beneath that silence, one of biology's greatest revolutions was unfolding. A large cell swallowed a smaller bacterium, but instead of digesting it, the two became partners. The smaller organism produced energy. The larger cell offered protection. This ancient partnership gave rise to mitochondria, the power source inside complex cells. Without it, animals, plants, fungi, and humans would never exist. Life had discovered cooperation. Over time, cells began joining together, dividing tasks, and forming larger bodies. In shallow seas, strange soft organisms appeared. Quilted shapes, discs, mats, and leaf-like forms resting silently on the sea floor. They had no teeth, no eyes, no bones, and no true weapons. For a brief moment, Earth's oceans looked like a peaceful garden. But peace would not last. A new invention was about to turn nature into a battlefield. The mouth was coming, and with the mouth came predation. Predation changed everything. For billions of years, much of life had survived by absorbing nutrients or drifting through the water. But once one creature could consume another, evolution entered a brutal new age. The ocean became an arena. Defenseless bodies disappeared. Others evolved shells, spikes, armor, speed, limbs, jaws, and new ways to escape. This arms race helped trigger the Cambrian Explosion, one of the most astonishing bursts of life in Earth's history. The seas filled with strange creatures unlike anything alive today. But the most powerful invention of this age may have been vision. Before eyes, the world was mostly blind. With eyes, light became information. Predators could track prey. Prey could see danger coming. Among the feared hunters of the Cambrian seas was Anomalocaris, a large predator for its time, with compound eyes, swimming fins, and spiked appendages used to seize victims from the seafloor. Yet life was not destined to stay underwater forever. Oxygen helped form the ozone layer, shielding the land from deadly ultraviolet radiation. The first pioneers were plants, fungi, and microbial life, slowly turning barren rock into soil. Then arthropods followed, ancestors of scorpions, spiders, and centipedes. Later, lobe-finned fish pushed through shallow swamps with muscular fins that hinted at future limbs. Life had crossed the great boundary. Earth was no longer only an ocean world. It had become a planet of forests, swamps, insects, amphibians, and rising possibility. As life spread across land, Earth entered an age of vast swamp forests. Giant ferns, ancient trees, and dense vegetation covered enormous regions. Oxygen levels rose, allowing insects and arthropods to grow to sizes that seem almost unreal today. Huge dragonfly-like predators moved through humid air, while giant millipede-like creatures crawled across the forest floor. The world was green, wet, heavy, and alive. But flourishing life was fragile before the power of geology. The worst mass extinction in Earth's history came with the Permian catastrophe, known as the Great Dying. In what is now Siberia, enormous volcanic eruptions released lava, carbon dioxide, sulfur gases, and toxins on a planetary scale. The climate overheated, oceans lost oxygen, acid rain fell, food chains collapsed. Most marine species vanished, and life on land was devastated. Earth became a wounded planet of heat, poison, and silence. Yet extinction also creates empty space. From the ruins, surviving reptiles inherited new opportunities. Among them were archosaurs, the group that would eventually give rise to dinosaurs. Slowly, they diversified, grew larger, and became dominant. Then came one of the most spectacular chapters in Earth's history, the Age of Dinosaurs. Giant sauropods moved like living mountains. Pterosaurs ruled the skies. Marine reptiles haunted the oceans. Predators evolved into terrifying hunters. And near the end of their reign, Tyrannosaurus rex appeared, massive, bone-crushing, and powerful. But even nature's greatest empire was defenseless against a disaster from space. The end of the dinosaurs began with a light in the sky. A massive asteroid, roughly 10 kilometers wide, raced toward Earth and struck near what is now the Yucatan Peninsula. The impact released unimaginable energy. Rock vaporized. A giant crater was carved into the planet. Heat burned life across vast regions. Shock waves flattened forests. Earthquakes shook the crust. Mega tsunamis surged across oceans. But the deadliest effects came after the impact. Dust, soot, sulfur, and vaporized rock spread through the atmosphere, blocking the sun. Plants died. Food chains collapsed. The giants that had ruled Earth for more than 160 million years could not survive the darkness, cold, hunger, and ecological collapse. The dinosaurs vanished, except for one surviving branch: birds. Beneath the ruins, small mammals endured. They were not powerful, but they were warm-blooded, adaptable, and able to survive on insects, seeds, scraps, and whatever remained. When the dust cleared, mammals rose. Some returned to the oceans and became whales. Others became elephants, horses, cats, bats, and primates. In Africa, one branch of primates developed grasping hands, forward-facing eyes, social intelligence, and larger brains. Climate changes pushed some of our ancestors from trees into open savannas. They were weak compared to predators, but they stood upright. Their hands became free. They made tools, controlled fire, cooked food, built tribes, and created language. Eventually, Homo sapiens appeared. In the smallest fragment of Earth's history, humans planted seeds, built cities, created writing, raised empires, crossed oceans, reached the moon, connected the planet through the internet, and awakened artificial intelligence. Humanity is young, fragile, and brief. Yet we have become powerful enough to reshape the planet. The question is whether we will have the wisdom to remain.